David Ken here with another question from your Hayes and Harris Math SL textbook. This is Chapter 6A.2, Question 2, Parts A and B. Once again, we're given two quadratic equations, and we're asked to solve, this time though by completing the square, which is a method for solving quadratic equations. When we want to complete the square, what we're talking about is using perfect squares for quadratics which aren't necessarily perfect squares. So if you remember, perfect squares is where you have a term squared so that you multiply ax plus b by itself. This gives us ax plus b times ax plus b. And then when we FOIL that, we take first ax squared, so that's ax squared, that's ax times ax, a squared x squared. Then we have ax times b, so that's abx, and ax times b, so that's abx. That's two of them, so that's 2abx. And finally, b times itself is b squared. This means if I have a quadratic in this form, it's equal to this form. And what I'm going to try and do is manipulate these equations so that they're in this form. And let's take a look at how to do that. Let's start with part A. We'll start with x squared, take 4x plus 1 equals 0. And we notice right away that it's not quite right. This could work. This could be in the form a squared x squared if a were 1. And this could be in the form b squared if b was 1. But if a and b are both 1, then 2ab is not negative 4. So this is not in a perfect square. We're going to make it a perfect square. I'll start by moving the 1 to the other side and just leaving a blank here. There's nothing there. This is plus 0. Now I need to figure out what goes in that blank. So we'll take our form, ax squared plus 2abx plus b squared, and we'll try and fit things into this form. First off, we see that if we're in this form, then a is equal to 1. There's an invisible 1 here, an implied 1 in front of the x squared. So a is equal to 1. Similarly, again, when I look at the coefficients, negative 4 has to be equal to 2ab. Negative 4x has to be equal to 2abx. The x's cancel out though. That's why I didn't write it a second ago. We can ignore them. Dividing by 2, we get negative 2 equals ab, but we already know that a is 1, which means that b is equal to negative 2. Which tells me what belongs here, negative 2 squared. So I'll put that in there. X squared, take 4x plus negative 2 squared. This imbalances the equation though. I can't just insert numbers wherever I want all the time. So if I add negative 2 squared on this side, I have to do the same on the other side, negative 2 squared. I have perfect squares format on this side. So we're of this form, so we can transform to this form. That's going to give me a, which is 1, x, plus b, which is negative 2, squared is equal to negative 1 plus 4. That'll be 3. Taking the square root of both sides, I get x take 2 is equal to the square root of 3. But anytime I take a square root, I have to remember that the result could be plus or minus. Final step is to move the 2 to the other side, and I get x equals 2 plus or minus root 3. And those are the exact solutions to the quadratic. We'll try part B now. We'll use the same tools. So we'll go to part B. X squared plus 6x plus 2 equals 0. And once again, we're not in perfect squares form. This could be a perfect square, x squared, but 2 is not. So what we're going to do is move the 2, excuse me, over to the other side to make room for what should be here. Using the form a squared x squared plus 2abx plus b squared, I'll determine what a and b should be. Once again, we see that a needs to be 1, and at the same time, 6x needs to be 2abx. The x's cancel, and dividing by 2 yields 3 equals ab, but I know what a is. So b has to be equal to 3. Which means what belongs in this gap is 3 squared. So let's put it in. X squared plus 6x plus 3 squared equals -2. And to keep the equation balanced, I'll add 3 squared to this side as well. This is perfect squares. It's x plus 3 squared. And on this side, I have 9 take 2, that's 7. Taking the square root of both sides gives me x plus 3 equals plus or minus the square root of 7. And finally, subtracting 3 to the other side gives me -3 plus or minus the square root of 7.